Hi everybody, welcome to another video in Pre-Calculus section 9.1. Conic sections. First what we have is a double cone. So we have a cone and a cone. Both of them drawn at the vertex. Each one of them is called an apple. And we will have the cone. Of course, we have the generator is a line, and then just rotate to generate a cone. We have the axis that go to the vertex right at the center of the cone. Right. Now, the conic or the conic sections are curves. So first of all, the cones are in three-dimensional object. The surface of the cone. The surface of each cone or two of them is two-dimensional. But when we talk about the conics or the conic section, it is a curve. A curve is a one-dimensional object. We'll talk about a curve. Something like this. Just one direction, forward and backward. So just one dimension. One-dimensional object in the two-dimensional space, meaning we have a curve in the plane like this. Right, so it is the result of an intersection of the right cone and the plane. So we have those and the intersection with the plane. Now we have a double cone and then a plane. If the intersection, if we have the plane parallel to the surface of the cone or perpendicular to the axis, then we generate a circle. Now, if we tilt that at the corner at an angle, what we have is an ellipse. And an ellipse, a circle is a special case of an ellipse. Now, if we have a plane cut only one of the cone, the surface of the cone, then we will have a parabola. And if it intersects two surface of the cone, we have a parabola. So those are the special conic section that we have. And we will not study the case where the plane go to the vertex. So the circle is where we have the surface of the cone intersect with the plane. So the plane and the cone intersect, make a circle if the plane is perpendicular to the axis of rotation here. And if it tilt at an angle, it will be an ellipse. And have the parabola. If it intersect one cone and intersect two cones, we have the parabola. By the way, when we go to the next section, define each part of the conic section, we will not use this definition. This is the classic definition of conic section. It is from the cones, therefore conic section. Once again, we will not study the case where the plane go through the vertex. Those are called the degenerated conics. Right, and conics we have a lot of application in real life. Also, when we have to the example, we have to each section. We will talk about those applications later. But that's all I want to go over in this section. Hi everybody, welcome to another video in Pre-Calculus section 9.2. The parabola. Out of those conic sections, this one has the most application in real life. Parabola. A parabola is the collection of all the points in the plane that are the same distance from a fixed point F as they are to a fixed line D. So what we have is a fixed point F called the focus and a fixed line D called the directrix. So in this case, what we have is a fixed point here F, that is the focus, and there will be a fixed line that is called the directrix D. The collection of all the points that are equidistant to a point and to the line is called the parabola. So the point F is called the focus, and the line D is called the directrix, and the collection of all those points that are equidistant. So this distance from this point to the line is the same as from that point to the focus. Right, for example, the distance from the graph of the book is not really good, but the distance from the focus, from the point to the focus, will be the same as the distance to the directrix, and all of those points. For example, go to this point. Yeah, this distance the same as that distance. So as you see, this definition is different than the definition we have in the first section, but in geometry, that's how we define a parabola. But of course, what we have back in the coarse algebra, of course, the quadratic equation will represent by the graph of a parabola. Of course, those parabola will be the same. We'll talk more about the equation later, but so far we have the focus and the directrix, the line that go through the vertex and perpendicular to the directrix is called the axis of symmetry. Once again, it goes through the vertex, go through the focus and perpendicular to the directrix. The intersection of the axis of symmetry and the parabola itself is called the vertex. So those are the characteristics of a parabola: the focus, the directrix, the vertex, axis of symmetry. So those are the characteristics of a parabola. Right, we'll talk about the equation later. Now let's consider the graph of y equal to 1 over 4 x squared, and later on we'll see that equation. But for this example, the focus is here, will be at the point 0 and 1, and the directrix will be on the other side of the focus. The equation is y equal to 1, negative 1. So we have the directrix here, the focus here, the distance, as you see, this point is the vertex. The distance from a point on the parabola to the focus is the same as the distance from that point to the directrix. So this distance is equal to this distance. And likewise, we talk about this distance will be the same as this distance. So that is the definition of parabola. The distance from a point on parabola to the focus and to the directrix will be the same. Right, and this is the parabola. Right, now if we're talking about the line that is going through the focus and perpendicular to the axis of symmetry, so this is the axis of symmetry, and if we have the line go to the focus perpendicular to the axis of symmetry and intercept the parabola, what we have here, this is called the lattice rectum. And the length of the lattice rectum will be 4 times the distance from the focus to the directrix. Simply, if we talk about the distance, this is 1. And by definition, the distance from a point on the parabola, which is this point, is to the directrix. So this is 2. So this is 2. And the whole thing is 4. So the lattice rectum, the length is 4 times. Is equal to 4 times the distance from the vertex to the focus. Vertex to the focus. Right. Now let's go to the equation of parabolas. Of course, in cosine algebra, we have y equal to x squared is the simplest form of the parabola. Yes, now but we have different parabola. Could be horizontal, could be vertical. Right. First of all, if we have the y square equal to something, that's going to be horizontal. So the first two cases where we have y square equal to x, this is horizontal. And the other two cases where we have x square, it's going to be vertical. So this is horizontal. This will be vertical. Right. Next, focus on the sign. If it's negative, it will be on the left. It's positive to the right. Negative go down, and positive go up. So if it's positive, it will go in the same direction of the positive x-axis or the positive y-axis, meaning up or to the right. If it has the negative, it is opposite to the axis, y-axis, and the negative x-axis. Right. And wherever the direction of opening of the parabola, the focus is on the same side, the directrix is on the opposite side. So what we have in general, it doesn't matter. Let's say we just have a parabola open to the right, for example. If it open to the right like this, then we have the axis of symmetry, the directrix is on one side, the focus is on the direction where the parabola opens, and the distance from the focus to the vertex is a. The distance from the vertex to the directrix is also a, but one is on the same direction as opening, that is the focus. The directrix is on the opposite direction, that. So we have to see the relation of this to write to link between the equation and the graph and the characteristic of the parabola. Right. Okay, actually we'll keep that for a moment. Next, analyze and graph the following parabolas. So, as you see all of those problems, I try to relate the equation with the graph and the characteristic of that conic section. So this is parabola. First, x squared. For example, y equal to x squared, that is vertical, right? So when we see x squared in parabola, that's going to be the vertical. Vertical parabola. And here we see the negative. The negative sign, meaning that's going to be opposite to the vertical axis, which is negative y-axis, meaning it's going to be opens down. So vertical parabola, that opens down. And according to the form, we have x squared equal to negative 4ay. That is the vertical parabola that open down, which is compared to x squared negative 4ay. And then we will match negative 4a with negative ay. So negative 4a equal to negative 8. So A is equal to 2. Now with that, we can graph the parabola. So first, in this case, when we have the equation in that, like that, the vertex is going to be 0, 0. So first we have the vertex is 0, 0. It opened down. So the vertex, from the vertex we go 2 units down to have the focus. So 2 units from the vertex to the focus, and the directrix is on the opposite direction. So this is the directrix. So we know the parabola is going to be in that case. Right. So let's write out the characteristic vertex x 0, 0, focus 2 units from it that open down, so it's going to be x equal to 0, y equal to negative 2, and the directrix y equal to 2. So those are the characteristics. Now in order to graph it, because we can draw the skinny or the wider parabola, but to determine the kind of the shape of the parabola, we use the lattice rectum, which is 4 times A, so 4 times that distance. So meaning we go distance from the vertex to focus is 2, we go 4 on the left and 4 on the right, and then this will be the parabola. So simple as that. So when we look at the equation, if it is x squared equal to something, that is the parabola that open up or down. Depends if we have negative, it's down, positive is up. If we have y squared, it's going to be left or right, positive to the right, negative to the left. And then we determine A, the distance from the vertex to the focus and from the vertex to the directrix. Next, find the equation of parabola with focus 0 and 3. So now we have the focus x equal to 0, y equal to 3. That is the focus, x equal to 0, y equal to 3. And the directrix, the line y equal to negative 3. So the directrix. So for this problem involving conic section, always link between the graph, the equation, and the characteristic of the conic section itself. So we have the focus and we have the directrix. Then we need to know where's the vertex. Notice that, like the previous example, the vertex is equidistant to the focus and to the directrix. So the vertex must be right in the, between the focus and the directrix. So this one we have the vertex. And then we graph the parabola. So let's write out the characteristic. We have the focus is S0 and 3. The vertex we found is 0, 0. And the directrix y equal to negative 3. So the distance from vertex to focus and vertex to directrix, A is equal to 3, and we need to know that to write the equation. We need to know that to graph it, of course. So from the focus, the distance that go, the length of lattice rectum is going to be 4 times that, going to be 12. So I'm going 6 to the left and 6 to the right. So have those points and connect them. We have the parabola. So that is the parabola. Now if we want to write the equation, this one open up or down, the equation is going to be x squared. This one open up, so it's going to be positive. It's going to be 4a times y. A is 3, so x squared equal to 12y is the equation. Right. Like I said, always link between the characteristic, the equation, and the graph together. Right. Next, find the equation of parabola with the vertex 0, 0. So we have the vertex 0, 0. And its axial symmetry is the x-axis. Axial symmetry is the x-axis, so it have to be open to the left or to the right, right? Because axial symmetry is that, so it have to be open to the left or to the right. Right, so we don't know that, but since open left or right, the equation has to be. So since we have axial symmetry is the x-axis, meaning horizontal axis of symmetry, meaning we have a horizontal parabola. So the equation is y squared equal to 4ax. Could be positive, could be negative. But since this one we have the negative x values, the parabola has the vertex here. In order to have the negative x values, it have to open to the left. So throw the negative there. Right, the rest is easy. I need to find a. When we have a, we can graph and we can come up with the equation. Right, now we can substitute negative 1/4 and 1 into x. So add negative 1/4 and 1, meaning x equal to negative 1/4, y equal to 1. So substitute that into the equation. Y equal to 1, x equal to negative 1/4. Negative 1/4 times negative 4 is 1. So we have 1 equal to a. Now with that we have everything. So the equation is y squared equal to negative 4ax. So y squared equal to negative 4. A is equal to 1. X, meaning that we have y squared equal to negative 4x is the equation. Right, like I said, always link between the equation, the characteristic, and the graph. Now how do we graph? In order to graph, we now go to the pole negative 1/4 and 1. Negative 1/4 and 1. So and from here a is equal to 1. We know that this is going to be horizontal, so open left or right with the negative, so it's open to the left. So meaning from the vertex we go 1 unit to the left, and that gives us the focus. 1 unit to the left, and because the directrix is on the opposite side of it, so it gives us the directrix. And then if we want to go through the focus, is the lattice rectum is going to be 4 times a, so we're going to be 4 times 1 is 4, so 2 up and 2 down, so we have 2 more points. And when we write the parabola, it will be So it will be that parabola that open to the left. So in the parabola, we need A, the distance from the vertex to focus, or from the vertex to the directrix. A is negative. It is negative, so it's open to the left. So we go 1 unit to the left to have the focus, and we have the directrix. So we have the equation. The focus 1 unit to the left is -1 and 0. The directrix is on the opposite direction of the focus, so which is x equal to 1. The vertex, of course, at 0, 0, that is given, because A is equal to 1. The length of Lattice Rectum is going to be 4 times that, so be 4, so 2 up, 2 down. That's what we have for that problem. Right, so up to this point, the vertex at 0, 0. Now if we have the vertex at different point h and k, all we do is just a transformation h and k unit is some particular solution. So just minus h minus k, so it will go h unit to the right and k unit to the left. So from the equation, now we just have different vertex, and from the vertex to the directrix and from the vertex to the focus, all of that's going to be the same, still A. So I have 4 scenarios here. So now let's look at the first example. The only difference here is we have the vertex. It's not at 0, 0. Right, so in this problem, find the equation of the parabola, the vertex at 1 and -2, x equal to 1, y equal to -2, x equal to 1, y equal to -2. That is the vertex. The focus is 2 and -2. So the focus is got x equal to 2, y equal to -2. So that is the focus. So with that, what do you think the parabola has to open? Is that on the left, right, up, or down? Well, we know for sure the vertex, the parabola have to go through the vertex, and it have to go around the focus, so it's going to open to the right. So I'm going to draw this case. Yeah, because we determine the rest later, so it's open to the right. Next, if we want the directrix, going to be opposite direction from the vertex to the focus. From the vertex to the focus, the distance is 1. So we can write that distance from the vertex to the focus. After we draw it, we see the distance is equal to 1, and that is going to be A. So the distance from the vertex to the directrix also A, but in the opposite direction. So we're going to have the directrix is the y-axis. And then if we want to graph, it will be simple now. A is equal to 1. The length of Lattice Rectum is going to be 4 times that. 4 times 1 is 4. So from the vertex, to the focus, we have 2 up and 2 down. So the distance is going to be 4. So we know how wide the parabola is. So that is the graph of the parabola. Now, if we want the equation, how do we write the equation? First of all, this one open to the right and horizontal. If it is horizontal, so horizontal parabola opens to the right. We have that from the graph, right? Vertex is 1, -2, focus 2, -2. It's open to the right. If that is the case, it is horizontal, so we have to start with y square open to the right, so it's going to be positive 4ax yeah. So y square and 4a is open to the right. Yeah, when we have y square, that's going to be horizontal. Right, and all we need to put here is the vertex at 1 and -2. So we have put 1 in for x to go with x, and -2 with y. So the equation is y plus 2 square equal to 4. A is 1, x minus 1. Yeah. So once we know the graph, the vertex, the focus, we know the graph have to open to the right, because the parabola go through the vertex and go around the focus. So we have the equation, and the focus, the directrix is the y-axis, or x equal to 0, and we have the equation of the parabola and the graph. So we good. So the distance from the vertex to the focus is equal to the distance from the vertex to the directrix, and we know the focus on the right of the vertex, therefore it open to the right. Right, more sample. Find equation of parabola with vertex 2 and 2, and the directrix is at 3. So the vertex at 2 and 2, x equal to 2, y equal to 2. This is the vertex. The directrix is y equal to 3. So directrix is y equal to 3. Y equal to 3. Find the equation and graph. Now just like the last example, from the vertex to the directrix is the same as from the vertex to the focus. So if the distance from the vertex to the directrix from 2 to 3 is going to be 1, so we have to go the opposite direction to get to the focus. So this is the focus, and the graph of the parabola will go around the focus through the vertex. So it's going to be like this. Once again, first we have to have the distance from the vertex to the directrix is equal to 1. So that gives us A. And so the distance from vertex to directrix is 1, and same thing, distance from the vertex to focus also 1. So since the focus is below the vertex, we will have the vertical parabola that open down. So have vertical parabola. Focus is below the vertex, so it's open down. So we start with x squared equal to 4a y, and whenever we have the vertex, just put into the equation. So that's what we have, and a equal to 1, and this one open down, so we have the negative here. So the equation will rewrite as x minus 2 squared equal to negative 4 y minus 2. Yeah. So very important in parabola, we need to identify either the distance from the vertex to the focus, or the vertex to the directrix. whenever we know the direction of the focus in relation to the vertex, we know the direction of opening of the parabola. Since the focus is below the vertex, it have to be open down, and therefore negative, and we have x squared and something y. Right. Now if we want to graph through the focus, we have the length of rectum is going to be 4 times that. This is 1, so going to be 4 times that, going to be 4, meaning we go 2 units to the right and 2 units on the left of the focus, and we have a parabola. Okay, because if we do that, the focus can be found as 1 unit down from the vertex. The vertex is 2 and 2. If we want 1 unit down from that, it's going to be 2 and 1. Right. Next, analyze the graph y minus 2 square equal to 4, x minus 1. So we have y. Subtract here. So first of all, if we're leading with y, it's going to be horizontal and it's positive, so it's going to be horizontal parabola because it starts from y square. And it's positive, so it's open to the right. And then from the equation, if we compare that equation with the standard form of the equation, y minus h square equal to 4a x minus k. So from here we have h equal to 2 and x equal to 1. So that gives us the vertex as the point h and k. H is equal to, sorry, it's always h that go with x and y go with k. So h is 1 on the x-axis and 2 on the y-axis. So we have the vertex is 1 and 2. X equal to 1, y equal to 2. And 4a is equal to 4. And we just match the 4 equal to 4a. So a equal to 1. Meaning that the distance from the vertex to the directrix and the distance from the vertex to the directrix and distance from vertex to focus is equal to 1. And so the distance, that distance is 1, and this one open to the right. So here we go 1 unit to the right. That gives us the focus. X equal to 2, y equal to 2. And the parabola length of rectum is going to be 4 times 1 just 4, so 2 up, 2 down. And we have the parabola. Okay, have like that. Right. And also, if we have the vertex on this side, the directrix is on the opposite side of that, but the distance from the vertex is going to be still 1. So from here we go 1 unit to the left, so the directrix is the y-axis, or x equal to 0. So we have directrix, we have focus, we have the vertex. So that's all we have for that parabola. Next, analyze and graph this equation. First of all, this equation is not in the right form as we have here. The right form is x minus or y minus something square. We know x square here, so we have to rewrite the equation first. So x square minus 4x, and move the 4y to the other side. Next, we need to do the completing square. So we need a perfect square on the left hand side like this. So I'm going to add something on this side. When we do that, we have to add the same thing on the other side. What we will add is going to be half of the middle numbers, and then we square. So take half of this, and then we squared. Half of -4 is -2, and -2 squared is 4. So we're going to add 4 on both sides. And so that will turn into a square. And so we have just x minus 2 squared. Fact out of 4. So we have the equation of the parabola is like that. So for this case, we can have the vertex. Okay, let's look at the vertex later. But first, compare that to the equation. That x squared, so it's going to be parabola. That x squared, so it's open up or down, right? Open up or down, because x squared positive, so it's open up. So parabola open up. The equation will be x minus h squared equal to 4a y minus k. Now we have the vertex. So 2 units down, so h is equal to 2. And k is -1. Notice that y minus k, this is +1, so we can write minus a -1, so k is -1. So we have the vertex x equal to 2, y equal to -1, x equal to 2, y equal to -1. That is the vertex. Parabola open up, and then we can match here for a equal to 4. So a is equal to 1. So this one open up, so the vertex will be, from the vertex to the focus is 1 unit, go up, so the focus is there. And the directrix goes on the opposite direction of that. So the directrix is y equal to -2, and the focus, we go 1 unit from the vertex up, so we go 2, -1, 1 unit up, it's going to be 2 and 0. Right. So we have the equation, and then we have the directrix, the focus, and the vertex. If we want to graph, again, find the lattice rectum. So we know the shape of the parabola. This time it's open up. Right. So once again, to get the parabola, we need to know the shape of it. Is that, and the direction of opening, up, down, left, or right. The distance from the vertex to the focus is a. distance from the vertex to the directrix is also a. And the focus, from the vertex to the focus, we will know the direction of the opening. Since this one open up and this 1 unit, so we just go 1 unit up from the vertex, we get the focus. Right, here's some application. I did mention at the beginning of the section, parabola has the most application of all of the conic section. And the most important properties of this is if we have the light source at the focus, when it hit the surface, parabolic surface, it will go create a straight line beam. So once again, if we have a source as the line at the source of light at the focus, when it strikes the parabolic surface, it will go straight. So when with this application is you can see is where we have a searchlight or something that we have the line that want to extend it for the furthest distance is the line that is parallel. So we have the light source at the focus, strike the parabolic surface, so it goes straight. Now, if you think that in the opposite direction, if we have the parabolic surface like this, if we have the parabolic surface, of course, if we rotate that, we have like 3-dimension parabolic surface. And instead of have the light source coming from the focus, now think about this. If we have the sunlight, if the sunlight we strike the parabolic surface, whenever it hit the parabolic surface, it will reflect to the focus. Now, if you open a flashlight up and get the parabolic lens, if you put a light source, if you put a piece of paper where the center at the focus, and to put that under the sun, when the sun, the light strike the surface, parabolic surface, it will go through the focus. So all the parallel line from the sun will hit the parabolic surface, go through the focus, and that point will hit it up and enough to burn to find a piece of paper. So if the piece of paper right at the focus and you put that under the sun, it will be enough to burn to find the paper. And that, of course, is the same principle of the satellite disk. You want to have the receiver right at the focus, so the signal that parallel and hit the parabolic surface will go through the focus. So the focus will collect all the light, so all the signal coming from space and hit parallel to, when it hit the parabolic surface, will go through the focus. So once again, if it hit the parabolic surface parallel to the axis of symmetry, it will go to the focus. And if it go from the focus, when it hit the parabolic surface, it will go parallel to the axis of rotation, axis of symmetry. Right, let's look at an example here. A sound like this is shaped like a parabolic revolution, so like this. The signal that emit from the sound like this are reflect to a single point. Right, so that is what we have. Where the receiver is located, if the disc is 6 feet across and opening 2 feet deep at its center, at what position should the receiver be placed? So where is that? Here. So all we have is, if we're going to rod, we know the focus. Let's say the vertex is at 0, 0. Right there. And the parabola, all we know is it go to the point 2 and 6. I mean, not 2 and 6. If 6 across, that's going to be 3 on each side, right? And it's going to be 2. So the point that go through has to be x equal to 3, y equal to 2. This one is the parabola that open up. Open up is going to be x minus something square equal to 4a y minus something. So this one open up. So that's what we have. We don't know a though, but we know the focus. I'm sorry, it's not the focus. The vertex is 0 and 0. So the equation x squared equal to 4a times y. We know x is equal to 3 for that point, where y equal to 2. So we have 9 equal to 8. So a is equal to 8 over 9. I mean 9 over a. Right, so 9 over 8, meaning that from the vertex to the directrix is going to be 9 over 8. So pretty much the coordinate of that from the vertex, we go 9 over 8. So it's about there. So that's going to be the focus. And so 9 over 8 unit from the vertex. So that is where we place the focus at. Right, so that's what we have for the parabola. So once again, for the parabola, the equation is either y minus something square equal to 4a x minus something positive or negative, or we lead with x. If we have y, that's going to be going to be horizontal. If we have x, it's going to be vertical. Positive is up. Sorry. And y square, so positive is to the right, negative to the left. Positive with x square is up, negative with x square is down. So if we lead in with y square, it's going to be left or right. If we lead with x square, it's going to be up or down. And then once we know a, we know the rest of the parabola. The distance from the vertex to the focus, and the distance from the vertex to the directrix. Right. So that's all I have for this section 9.2. Actually, I forgot to change till now. Right. But that's all we have. See you in another video in calculus. Thank you for watching.